So in this video, we are going to discuss the recently asked question in the Codeforces Educational Round 512 rated for Div 2. The problem name is array painting. So first, let us understand the problem statement. So problem has given us array and all the elements in the array are initially painted to red. And our goal is to make all the elements in the array to the blue. And we can perform this operation as follows. For example, if we have an element, we can paint that element from red to blue with cost is equal to 1. Or either we can say if any of its adjacent element is not equal to 0, then we can borrow that element and paint our current element with no cost into blue. But the catch is the element which is colored equal to which value is not equal to 0, that element cannot be initially be painted. For example, in this we have middle element is equal to 2, then we cannot consider that mine this element is already painted. This element is painted red. All the elements in the starting is equal to red. What we can do, we can provide one color to this and one color to his left and one color to his right with no cost, and we will paint the middle element. So in this statement our answer will be 1. Similarly, in this we can paint the, and see, if we have this element is equal to 1, then we can paint then we can paint its left element to the 1 and make it 0. Similarly, we have 1, then it's our choice. If then it's our choice whether we want to repaint this its left one which was become 0, or we can left this. So I will choose that my left element will be painted 1. So at the end my two elements will be remaining 0, and I will paint that element using my 1 cost. So answer will be 2. So I hope you have understood the question. So now let's begin to the solution. So there is a very pretty much observation in this question which you have to observe, then you can solve this question easily using greedy method. For example, if we have a subarray consisting of only 1 and 2, which does not contain any 0, then we can divide this array, or rather we can say this subarray can be replaced by only 2. For example, if we have 0 0 in the left and 0 0 in the right, then we can write it at 0 0 0 and 0. This and this is both the same thing. And similarly, in this test case, I can write this array as 0 0 1 0 0. Here all the sub and then here this sub array which is containing only ones will be considered as only one, and then we can solve this. You will now ask, how is this possible? So now I will tell you the intuition. First, let us say how this all ones can be become into only one. If I consider the consecutive two ones, this one can repeat this one can repeat this. So I will both cancel this out. Similarly, if I consider this can paint this can paint this, so this will become 0. And now I have left only with one element. So I can check if all of my adjacent elements are painted. Here only one is left. So I can similarly write one down and other zeros and other zeros, and these all are cancelled. So if the number of ones are odd, then we can similarly check if the number of numbers of ones are even, then we can similarly check. I can cancel this one from this one. I can cancel. So I can, what can I do now? I can paint my this one with this one. But now I will make my this array is equal to 0, and I will paint this one. But no one had painted this one, so this one is also will be left in the end. So my first is that if my array contains a subarray with only one, I can replace it with a single one. Now I can check how my array containing the element 1 and 2, that I can convert this array into subarray into an element which says with only 2. So I can check if this 2 is here, then what can I do? I can paint this one, I can paint this one. Now this will become 0. Now I can paint this one, so this will become 0. So now what can I say? I have these two, this one. Now I can paint this one, or I can paint this one. So this will become 0, and I have these two left. So now I have 1. What can I do? I can similarly check. I will paint this one. Now this will become the left. So at the end, I can see I have only 2 left in my array. So what can I check? If there is a subarray containing only 1 and 2, then I can replace that subarray with maximum of the elements. So I thought you have understood this much. So my first observation is that if my array containing all the elements, or if my array containing a subarray with only 1 and 2, then I can replace that subarray with the maximum element in in that subarray. So now what that after replacing the element, what can I do? After that, the problem pretty much remains as greedy, and we can apply the greedy approach to solve the further problem. So now here you can see this test case. So here we can say in this test case we have a subarray containing only 1 and 2, so I will replace it by 2. Now we have subarray 2 2, so I will replace it by 2. Now this is only single 1 and this is only single 2. Now rest element is my same. So but my final array becomes here 0 0, here 0 0 0 and 0 0, and here 1 0 and here 1 0. So now what can I do? Initially, in first run, I will run my loop multiple times. In this array, suppose this array name is V. So in array V, I will run my loop multiple times. In first time, what can I do? I can replace the 2 with 0, because no one will be painted 0. No one will paint this element which is equal to 2, because both the sides is either 0, or if it's a last, for example this is 0, this is 2, then no one will come and paint this 2, so this will always become 0. So we have to always pay for this 2 only. And what this can do is it can repaint this adjacent one. So what I will do? I will simply do. I will cancel this 2 and I will repaint this 0 as 1 and repaint this 0 as 1. So here this becomes 0 and this becomes 1 1. So initially now I have this, I have considered by this case. So now for example this paint is below. For now what can I do? I can replace my second 2 and make it 0, because no one will game and paint it 0, because no one will game and paint this 2 as blue. So I will what can I do? I will make it as red, because it was initially red only, and this is also red. So what can I do? I've used this 2, and what can I do with this 2? I can paint this adjacent one as blue. So I will paint this blue and paint it blue. And similarly my last 2, it will paint this blue, it will paint this blue, and it will remain red in the end. So I have run my first loop. In second iteration, what I will do? I will choose the 1 which have remaining 1. So what I can do with 1? I will check if the remaining 1 cannot, if the adjacent of 1 does not contain any blue element which was initially painted blue. So I will paint that element equal to blue, or I can say I will paint this element equal to blue, and no one will. And similarly, as we have discussed, that no one will come and paint 2 as a blue, so no one will came and paint 1 as blue also. So this my, so at the end my this one will also remains at red, and all the zeros which have not been touched yet, they are by default red only. So I can check. In this case we have at the end, we have at the end 6 red left. This one, this one, this one, this one, this one, and this one. So total 6 reds remains. So in this case we have answer is equal to 6. So if I discuss you with one more test case, I can simply check here. So here I can check. See, this array does not contain any subarray which only contain 1 and 0. These are all independent elements surrounded by only 0. So what can I do? I will initially check कि all my elements are equal to, all my elements are initially red. So I will write it. So I can check my initially all the elements are all red. So I will write it as 0 1 0 0 1 0 and 2. So if I run my loop greedily, so first I will choose the element is equal to 2, and what I will do, I will paint is adjacent one is equal to blue. So I will paint this blue, and this remains 1, and its value is decreased to, and its value will be decreased to 1. So but there is no benefits in decreasing its value, because it does not contain any adjacent other element. So I will make it 0, which represent no one is coming to make this element to is equal to, no one is coming to make this element to color blue. So what can I do next? I can do next, I will choose all the ones which contain adjacent element which are red. So here I will consider this one. It's all is both adjacent elements are red. So I will choose one of the my choice and make this is equal to blue and make this is equal to 0 because in the red because no one is coming to make this element blue. So by next I have this one left. So its right adjacent is already colored blue, so I will not change it. I will change the right one, I will change the left one which is initially red, so I will make it blue. And at the end I can check my how many elements which remains are equal to red. So 1 2 3 4. So in this case 4 is the answer. You can check it. So now I will show you this code, you will more understand this better. So here in this code you can check. I have created an array V. If my current element is greater than 0, I will run my loop until my subarray containing all the elements equal to 0, and I will figure out which is the maximum element. Now at the end I will just only put the maximum element in my resulting array, and if the current element is not equal to 0, then if my current element is equal to 0, then I will simply push 0 in the 0 in the array. Now if I run greedily, I will simply check if my current element is equal to 2. Then I will check if my adjacent left and adjacent right are both present and are not equal to red. Then because no one will initially be red, I will simply have to check the lower bound. If it isn't the first or last element of the array, then I will simply color it blue. Here 10 means color blue. And I will mark this current element which was previously equal to 2 to equal to 0. Now I will run the second loop in this I will check if my current element is equal to 1. If my current element is equal to 1, then I will check if my left adjacent is equal to 0, or means if no one has colored this left adjacent to blue, then I will simply color this left adjacent to 10 means blue. Or I can check if my right adjacent has not been colored yet to blue, then I will simply color this one to the blue and I will mark it as 0. And at the end I will check how many elements remain 0, or means how many elements remain in color red. Then I will simply increase my count and I will choose the operation of counting, in which I can buy the color blue and paint that red element. So this is the whole introduction of the problem. So if you like the video, please consider subscribe. Until then, stay tuned for the next one. Thank you.